I mean, look, we're squirting water in the air. That's a great point. And
Thing.
Was there more to that question?
It's like he's putting on a little clown show there. It's so goofy how they do that, dude. Like, if they were really there, like, it seems like there's so much footage you could get of them actually doing some interesting experiments or something that would be real, you know? But they're always just in front of the camera doing some weird little tricks, you know? And then putting that out, like, look, we're on the ISS. It's like their whole thing is just convincing people of goofy things, you know, in front of the camera. It's so strange.
Yeah, good point. Like, we're not working on this experiment. Look, we're squirting water in the air. That's a great point. But the other point also is it's not safe. You have water floating around. You don't know where it's going to end up. You're in an environment that you can die at any moment, and you got like hair floating around, water floating. Like, it just doesn't make sense.
Yeah, but he's in a watertight room. I mean, it's not like there's electronics and cables and wires and laptops all over the walls or anything.
Exactly. Yeah.
Yeah, there's like literally laptops just there. So if one of those little drops of water, you know, went over, hit the laptop, shorted out the laptop, now what are they going to do? They have to now go all the way down to Earth to get another laptop? I mean, how many extras do they have up there? I know, there's a million reasons. That's totally impractical and just straight up dangerous.
Yeah, what do you guys think the ISS?
Go ahead.
What do you guys think you guys, do you agree that you can see the ISS on certain days pass in front of the moon?
An object, yeah. There is an object that can be seen. Yeah. Seafoam just grabbed it the other day, live on here. He got a shot of it.
That's awesome.
Yeah.
What do you guys think it is?
It's a space station with humans in it orbiting, free falling around a sphere in a vacuum. You know.
Oh, I understand. You definitely don't believe that, but I'm curious. What do you think it is?
Well, it would be in the realm of
speculation. I've been answering that for a long time. It's what I think it is. It's a military drone. It's a military vehicle, because the number one objective of the military is to get a bird's eye view to see what's happening in the battlefield, right? So that's what personally, I speak only for myself. That's what I think it is.
There's also an idea that
aerodynamic.
Well, there's an idea too, which there's an idea that like there actually could be a medium up there, like a superfluid or a liquid or something where you actually could throw something up there and it would actually move on its own, like a superfluid. So almost like imagine if you have like you have a stationary planar Earth, and then above, like, just for the analogy, let's just say you have an ocean up there. You know, an ocean, but it's a different type of water that's able to stay up there. Like, I'm just saying. And then the idea of, let's say that ocean is flowing quickly. If you then threw something up there into the ocean, as it were, into the water, it would then go along with that water. So, I mean, that's just a very crude kind of way to describe it. But so yeah, there is an idea, because what's interesting is when you look at, I'm going to pull up, if you look in the chat, I'm going to post this. A few things. If you look in the live stream one text, here, I'll tag you. But you see, like, that's actually the path of the ISS. That's over like an AE map. But even if you look at it like on the globe, like, it seems to make this pattern. It's like the flower of life pattern, and it matches the way a magnetic field flux lines look. So if you look at this image too, it shows it next to a ferrocell with ferrofluid. With a magnetic field. So you see the striking similarity there in terms of that. Now, that is like an AE map kind of layout. But then if you look at this is, well, this one might take a minute to upload because it's a video. But basically this one is shows sort of the animation of on the two, like on the globe, essentially like what it's doing on the globe, and then with an AE map. And that one kind of shows the AE map kind of rotating, which is kind of funny. But so I'm not really like backing the whole way that's made or anything. But I'm just saying, just in general. So it's like the thing they call the ISS seems to make this like sacred geometry, flower of life, magnetic field pattern. So is that just a coincidence, or it just happens to be? I mean, I guess, there's different, but I'm just saying with that, there is the idea that they could actually put stuff up there. Not that humans could necessarily go up there, but that you could throw an object up there, then the object would actually flow. It would move on its own, basically, with whether it's superfluid or something to that effect. So it's not really the same idea of gravity and free falling around a sphere the way a globe is. It would be kind of like an orbit, though, I suppose, but it would be above a planar surface. So I'm just saying that's just in the realm of speculation. That is one idea that has been brought up as well. So like SE said, it could be like a drone or a technology, that they may not necessarily even be telling us about. So it could be some kind of craft or something like that. Or it could be that you actually can put stuff up there, like not like humans in that way, but that you could put an object up there that would flow in that way. And then the last one that's been discussed is that it's maybe like an actual optical, like a hologram or a projection or some kind of like a like the bat signal thing when you can, you put the Batman sign for the big light and it shows it. So yeah, something like that would be able to be kind of projected. That's another option, possibility.
I'm kind of curious about the second one. If you think that that's possible, you can throw an object essentially so high that it gets into the second medium without going through the firmament or destroying whatever's protecting the dome or whatever. Hypothetically, you could put a person in there, right? So you hypothetically could get to some like weird ocean type sky space.
Yeah, but if the superfluid acts differently, right? Think of it this way. If you were coming from above to below, you would be going
I
through
love
this.
coming from above. Sorry.
Well, keep that to yourself. Um, and you start going towards the surface here, you would be able to effectively go into a liquid being the ocean, right? And that's a much more dense, thick fluid, which would actually somewhat slow you down compared to the thinner fluid of the atmosphere. But if you have this superfluid, which actually uh, would increase, would be more um,
Yeah, like less viscous and more.
less, yeah, less viscous, but still a fluid. You could imagine that being separated from what would be a more viscous air type scenario, right? So it wouldn't necessarily have to be some dome or physical structure or anything like that. It just could be the same thing in the opposite direction, dealing with fluids of different you know composition, if that makes sense.
Yeah, with like very little resistance. Yeah, that is interesting because like when you think about it, like you're in the ocean. Like if you were in the atmosphere, 1,000 feet up, and then you free fall, you're gonna free fall. You're gonna move very fast, and then you're gonna hit the ocean, splash. You're gonna hit the water, and then you're gonna obviously be slowed down significantly, and all of that. And then you're gonna float there unless you swim down, whatever. So obviously we know the difference between water and air is very different. But what if it's like the opposite when you go up there? Like instead of it being more viscous up there the way the ocean is, it's like it's less. It get less and less, and you get that's like the idea of superfluid. So if there is some kind of liquid up there, it would make sense to me that it's not the same water, like the denseness of what we have in the oceans and on Earth. So is that what you were kind of alluding to, Napalm? That it would actually like go the opposite way to where to get less viscous and less resistance to where
Yeah,
you know
yeah.
some,
Just to kind of piggyback on what you were saying there, that would be my conception of that, right? It's being separated not necessarily because of some sort of physical barrier that would be hard to penetrate. It's just a separation of the fluid from the air in the same way it is down here, but based on other properties.
And don't forget a super solid while you're at it. There is such a thing as a super solid. I know it sounds crazy, but yeah, you can add that to your mix if you want like a barrier type thing. Which, believe it or not, is also um, zero viscosity.
it is wild to think about that if you go up like so it's like a few things could happen when you go up really high. like really, really high. Either you do hit some kind of barrier, you shoot out into outer space and start free falling around a sphere, or this idea that there could be like a superfluid that is actually, like Napalm was saying, that you wouldn't really hit a limit. You would actually transition, just like you do when you go from water to air or air to water. You would transition from what we call air, atmosphere, into what that medium is, which is pretty interesting. And then, I mean, could they put satellites up there in that way, like into a superfluid or into like an ethereal superfluid? Like, could they
Yeah.
fire up satellites to get a type of an orbit, as it were?
Yeah, I mean, think of the context that this was brought up was regarding what the ISS might be, right? So if it's in that fluid and it's has the ability to hold the object, but also allow it to move at a much faster rate, meaning you're not having to deal with the aerodynamic limitations that you would have in like the normal atmosphere. That could account for the speed in which it's traveling.
Don't think it has any holding properties, though.
Yeah, I'm
Because
not
of
sure, but there's a possibility you're also dealing with something that may be utilizing Earth's magnetic field or frequency like that in order to levitate as well. Some type of quantum locking involving the Earth's magnetic field. It's a possibility.
Yeah, I've actually talked about myself the quantum locking, and I've even checked to see if it's cold enough, and apparently in their paradigm it is cold enough. So keep in mind, we're just speculating here, guys. Don't get all worked up. This is just speculation.
Yeah, this is all speculation. I've never been at extremely high altitudes. I don't think anyone in here has, so it's going to be in the realm of speculation. Unless you want to compile or deduce certain things based on other information, you can. But yeah, in terms of,
I mean, don't you
Yeah,
hate
but
that
that,
you have to like literally preface everything with the possibility of speculation? And even doing that, people are still going to come back and be like, "Well, a flat earther said that it's this, so therefore, blah blah blah." The same way everybody gets,
yeah, but
straw
if you look
manned
at the
into a
old,
dome every day.
That,
if you
that's
look
why I
at the
did
old
that, because you can
research,
hear.
guys, if you look at the old research of superfluid helium with its super viscosity and its Fontaine effect, and with the charge going from the bottom to the system to the top of the system, and it even can climb walls. So it is a perfect thing for a container for our system. And that temperature, you're right, that is almost exactly as the temperature they tell us that that barrier has.
Yeah, for the quantum locking, right? It has to be like very, very cold. So yeah, and we have the magnetism, right? We know the Earth has magnetic because of our compass, right? So yeah. Once again, it's all speculation.
Would you guys agree that we can see like other things in the skies that are moving at like different angles than the ISS? Because like it sounds like you guys largely agree. Maybe yeah, it could be a hologram, but it seems like there is something up there. We can look at it, and there are other things like other satellites up there that are moving at like different angles
Nobody
to
said
what the ISS
hologram.
is.
Sorry to interrupt you, but nobody said hologram today.
I could have sworn maybe it was Napalm. I'm sorry,
no,
I'm
I
not really
said
looking
that.
at the thing.
No, I said the word.
Okay.
Yeah, I was saying, well, the idea that the object they call the ISS is a projected of some sort. I did mention the term hologram.
Oh, my bad. I didn't hear it. My bad. Okay.
How
Yeah,
dare you,
I
sir?
mean, again, prefacing complete just speculation is I'm just saying if it's a projected object, and people like to chuckle at holograms, but holograms are very real, and they can be projected and all of that. So I would not put it past the government to use that technology. I'm not saying they are using it for that particularly, but yeah, but carry on. But I did mention that, yeah.
Yeah. Hold on. Let
But
me
you guys,
piggyback on what Gio just said. Not only are they real, but I've read that the military can project a hologram, and it can also be picked up by radar, perceived as a real target. I'll try to find that and post it.
Yeah, that's what they did with the Battle of the Beams. That's just crossing two radio beams to get at a certain point.
That's not a hologram though.
No, what I'm talking about is more than a hologram. It's
Yeah, I get what you're talking about.
yeah. I forgot what they referred to it as. Was it a laser? I forgot what it was, but it was able to be picked up by enemy radar and perceived as a threat, as a target.
Wow, just projected light. That's pretty interesting.
Yeah, a projection and being able to pick up as a target, like as a radar bounce. I don't know how the heck. I'm gonna try to find it because I don't remember the details.
I'd like to see, this is kind of for something in the future, but I've always wanted to know with the ISS path what it does over the oceans, like the Atlantic or Pacific. Like, is it also has anyone picked it up from the deep oceans, Pacific or Atlantic? Basically, what that would mean is that I guess what that would link to, and the idea that it's a projected light object of some sort, that are they doing it over the oceans as well, or do they only turn it on when it's over land? Kind of idea. Like, is it actually, yeah? Because if it's projected, like, would they waste the energy to do it over the deep Pacific Ocean that nobody's there? I guess you do have like Hawaii out there though, so but I guess in the Atlantic there's not too much land in the middle there. But it would just be something interesting to see if it can be seen in all positions, including the oceans.
I feel like it would take a ton of power to project something like that so high in the atmosphere, all over the Earth, kind of like all the time. The number of stations you'd have to project this thing up there, it seems like it'd be more complicated to do that than to actually put something up there.
Well, yeah, I mean, but if there's like a superfluid thing you could put something into, that's one thing. But I mean, the speed that it's going, that's the thing. Like, in terms of all that, we could get into all that, like whether speed can be isolated in that way. But I mean, you can track it, and then you can have a friend tracking it. Like, you could be in one, like in New York, and then another friend could be in California, and you can track it, and like that 17,000 miles an hour can be seen that way. Like, it is cooking at that rate. So that it's like, is there any type of physical craft that could do that? Whereas a projection obviously could. But that's why I was saying the Southern Oceans, because if it is a projection that has like multiple stations that they have to have it, they pick it up from New York to, to Tennessee, and then from Tennessee to, if there's like several stations or something. That's what I was saying. Like, if that's the case, would they even bother to do that over the oceans? Which is
well, the ISS spotting applications will take your location and predict when it's visible. So if you're on a cruise ship, does that just going to stop working? I mean, there's all kinds of shipping across the oceans.
Yeah, I mean, so that's true. So has anyone caught the ISS though from a cruise ship or from the oceans? I mean, it sounds like somebody that would be a huge gap in their deception to be like, oh yeah, there's just no ISS in the oceans, and like you said, all it would take is a cruise ship or somebody that's tracking it to. So yeah, it wouldn't make sense that they wouldn't have it in the oceans as well. That would be such a gap in their whole thing.
It's not like the app would then say, just return no information.
Speaking about that app, I don't know which one you guys use, but I've used I forget the name of it. It was an official app from the ISS, and I would get like 3 out of 5 times it wouldn't be where it says it was. I don't know what kind of experience you guys got. Did you always find it where the app said it was?
Every time I've tried it, yes, it's been right there.
See, I've had a different experience. Anybody else use the app?
And of course, that would include Jaren photographing the ISS as it transits the moon, not just the visible while it's passing to the umbra.
Well, I don't doubt there's a thing there. I filmed it myself. It's on my YouTube page. I mean, I just got a light because I did it with a P900. But I'm not denying there's definitely something up there. Now, is there people inside with hair flowing around and throwing water all over the place? No way. No way. In my opinion.
I mean, if it is like a superfluid though, like if there is a physical object up there, hypothetically, there's no reason why you couldn't put a person in there too, right?
No, but you still wouldn't be that willy-nilly in your shorts and like, doing these crazy things, throwing water around, doing your business in a tube where, sorry to say this, but feces could be flying around, hair flying around, sweat flying. I mean, no, bro, that you wouldn't be doing that.
I mean, they are people. They gotta like have some fun sometimes, right? They're up there for what is it, like 6 months at a time?
Yeah,
I
and
don't know what the average shift is, but
Yeah, but there's
I would
another
assume they get
thing.
up to some silliness.
There's a CIA document that states that the centrifugal vortex of Earth only starts at 1,000 kilometers up. And with ISS only 400 kilometers up, that's not even halfway in the centripetal vortex. So that would mean that it would always be pulled down to the Earth instead of being going up in the air. So they need force then to keep that thing up there. Otherwise, it's impossible.
Well, it depends on how fast you're going, right? That determines what your orbital velocity needs to be. You're saying that CIA did an evaluation of NASA's proposed space shuttle and they got the altitude wrong?
No, they tested apparently the centrifugal and the centripetal vortex of our world. And that centrifugal vortex only starts at 1,000 kilometers above the ground.
I don't know what that meant. What's a centripetal and centrifugal vortex?
Centripetal
Is that what you
is the
said?
force going to that pulls you to the ground, and the centrifugal is the force that pushes you away from our world.
Yeah, no, I understand centripetal and centrifugal. What does that mean in context with a vortex? I don't know what that means.
Because it goes from small to wider, and from wider to small again. So that's the vortex. You're going in circles from you're going up or down. It's a vortex that goes two sides.
What?
I don't understand.
Yeah. If you're spinning a rock around on a string, you're spinning it around your head. Is that a vortex?
Yeah, it slings out from small, but it slings out wider and wider. It goes further away from you instead of coming to you.
See, the issue is not that there's something up there, right? There's definitely something up there. I mean, if you don't believe your eyes, that's on you, right? The question is it in a vacuum of space? That is the issue that I'm contending, and I'm saying no way, that's physically impossible.
What do you understand a
There's
vacuum
no
to
such
be?
thing as a vacuum of space, because a vacuum is void space. It has no elements to create anything, so there can't exist anything.
Well, a near vacuum, because there's no such thing as a vacuum. So let's get that straight out of the way. Yeah.
Yeah. So there is like some on the globe model. There is some stuff up there, right? And you guys all understand vacuums don't actually suck, right? It's the high pressure pushes into a lower pressure area, right?
Exactly.
Yeah. So why doesn't that happen in this model that you guys seem to believe in? Why doesn't that happen in this instance? What you just said, Fingland.
Sure. Yeah. You're talking about on the Earth. It's because of the downward acceleration.
Because of gravity, right?
Whatever's causing things to go down, I think we can all agree something's causing things to go down. It's because of that, whatever that thing is.
Okay, but even in that paradigm, right? It's the weakest. It's one of the weakest, quote unquote, force in the Ball model, right? So, are you like just think
Sure.
of critical thinking, even in your model? can the lightest, the smallest force, can it combat all that's said near vacuum of your cosmos? You think that's physically possible?
What kind of force is the vacuum exerting?
By the way, it's not a
Yeah, I'm not.
downward force. The force is the upward acceleration of the Earth towards the object, not the opposite.
Yeah, so what's going to win out? What do you think is going to win out? The gravity, which you think is causing the atmos, and we'll leave the water out of it, but you think that's sufficient enough to combat the whole void, the whole yeah.
Well,
Think
what
about
is the force? What is the force that you're referring to? A vacuum really is not anything. It doesn't exert forces. It doesn't do anything.
Yeah, I
Well,
thought we
let's think
agreed.
about
Go ahead. Sorry.
go ahead.
Well, I thought we agreed that like a vacuum is just less particles in a given area compared to another area, and that vacuums do not suck. It is high pressure pushing into lower pressure area. If there's a whatever the downward acceleration is, obviously that's what's causing the density gradient in our atmosphere. I don't see why there's like I get conceptually it's kind of strange to say there's so little up at a certain 100 miles up that we can effectively call it zero. But I don't see, if you do understand that things go down, then why would, like the other guy's saying, why would the air just suddenly fly off? It doesn't have an infinite amount of energy to escape the gravity well of this planet or whatever pulling shit down.
Well, that's what I'm trying to explain to you. I'm trying to explain to you that in your paradigm, gravity is one of the weakest forces, if not the weakest force.
Yeah, but
And
no
then you
forces
have,
are acting on the air besides gravity.
but didn't you say that the particles tend to go to the vacuous part?
I said high pressure pushes into low pressure, but
Okay, and where would the
if
high
they're
pressure be in your model? Where would the high pressure
on the
be?
ground, but it needs
And
enough force to be able to escape the gravitational force exerted on it by the mass of the planet, right? So, like, if you had a super deep well and you didn't have enough water to overflow it, of course the water's going to stay inside the well. And it's the same thing with the atmosphere. There's not enough air on the planet that it starts spilling outside the gravity well or outside this area, the downward acceleration. It doesn't have enough. Some of it does. Some of it gets enough energy. Certain particles are struck by others coming off the sun, and they do escape the atmosphere, but it's not a lot. And they're the smallest ones because they're the only ones that can be imparted with enough force to get outside of the gravity well.
well, that's another issue, escape velocity. We can get into that. That's 25,000 miles an hour. You think that a particle here on Earth can achieve an escape velocity of 25,000 miles an hour?
I thought you were saying that they all would.
Well, yeah, obviously. If you think about it,
What?
yeah.
Are you?
Right now, if we were in a vacuumous area, we would all be dead right now. There's no way around it. That's physics. Like, do
We
you
would
think that
all
you can
extinct in
reproduce a
vacuum.
gas ball in a vacuum chamber? Obviously, that's a silly question, right?
Sorry, I didn't quite catch your silly question. What was it?
Do you think that you can reproduce a ball of gas in a vacuum chamber?
I don't think anybody says that you can.
Well, that's what you claim your model is. That's what you, not only do you claim that we can, you think we live in such a system. That's your model.
Well, I mean, you'd have to literally do this to scale, where there's enough mass that causes the particles, the gas particles, to cling to the ball. That would be an incredible amount of mass to try to shove onto something here on this planet, because we do have the gravity of the planet. You could go out in space and try, but I don't think you're gonna. agree if somebody actually did that with the results, right?
How are you going to eliminate? You can't eliminate gravity. You think there's no gravity in space?
No, there
In
of
the
course there's
ISS, for
gravity in
example?
space. There's just way less, depending on where you are.
Okay, but you know, on the ISS, there's still gravity there, right?
Yeah, of course, some like 83%. They're just essentially in free fall, though.
Okay, right. Okay, good. Okay, right.
Well,
All right.
I think he gets confused on his model as well because basically everything is in free fall. That's the whole point. There is no like. I know you think the conception of a gravity well is that it's holding things in or that it's pushing things down or that there's some sort of pushing force that is allowing objects to appear as though they're moving towards the surface. But in reality, your current model is that the surface is rising up to meet the object that is being dropped because that object is in free fall, meaning there's no forces acting upon it. So the only force or the only acceleration would be the upwards movement of the surface to meet the object.
Depends on where you're describing that force from, what reference frame.
Yeah, you can
That,
say it from either
that
one. You can say
that is
the ball
the
is coming towards
reality.
you, or you're going towards the ball.
Yeah, that's cool. So where is the measurable force? Do you have the measurable force on the surface of the Earth, or do you have the measurable force when the object is in free fall? When the object
No,
in,
you
in
don't have a
free fall,
measurable force when it's falling.
correct. So where's the force coming from?
Once they're in contact with each other.
But okay, so the ball that you dropped when it's in contact with the Earth, is there a measurable force there?
Yeah, like you can hold an accelerometer in your hand while standing on the ground, measure that. Like standing on a scale is literally measuring the acceleration downward. As long as you're actually standing on something. If you're standing on a scale when you jumped out of an airplane, the scale would read essentially zero.
Right. So that in your model, right, the idea or the conception of the bending and warping of space time, the actual force being applied is from the surface upward to the mass that's residing upon it.
Like I don't want to sound dismissive, but it's like it gets into really bad semantics, and I'm not like a physicist, so I don't want to speak as though I'm some kind of authority on this. There's a downward acceleration that we measure while standing on this earth. Do you agree with that?
Yeah, yeah. There's an agreed upon
Of
average
course.
of an acceleration of objects, yes. And
Yeah.
the cause of that acceleration is what's under question. There's a conceptual model where they take privations and they give them properties and say that because these two things are doing something that we've never actually proven, this is our theory on why this is happening, right?
Mhm. Yeah. And they come up with predictions and they do derivations, and
Yeah.
most of
Yeah,
those
yeah.
things come out to be within the margin of error. And I think that's exactly what we should be trying to do.
Yeah, yeah. Conceptual models can give you predictions. Doesn't necessarily mean that the conception is the reality.
Yeah, reality can be modeled.
Doesn't mean that the
A
conception
model
is
is not
the
reality.
reality. Correct.
Well,
Yeah, exactly.
the thing, if you model it, you're making predictions,
So
and the model actually, is accurate and it has utility. You can use it.
Is anybody else able to hear that?
no, he's just saying because the model has utility, therefore you can use it. We understand that modeling can have utility. It doesn't necessarily mean that that model's utility or accuracy means that the explanation is correct.
Sure,
Because
but
there's
if it has
alternatives that give you
utility,
the same predictions. So that's all I'm saying.
you have an alternative.
Yeah, there's many different alternatives. Just go ahead and do a little research on the internet. You'll find a bunch of different alternatives to the theory of relativity and the bending and warping of
Well, I mean,
space-time being the causation of gravity. There's plenty of them. There's been so many debunks of that one. There's been so many alternatives to that by highly credentialed people that it's ridiculous and almost laughable that it's still taught. That's the funny thing about it.
sure, but like I'm not a high level physicist. I'm not going to be able to validate it one way or another. I just hear consensus on these things, but like the more practical, everyday man stuff, I know I can go out and verify 9.8 meters per second squared downward acceleration, right? Like that. Say whatever you want about
Yeah,
relativity.
but
That's
that
definitely
measurement
accurate.
that measurement was made well before anybody decided to come up with a conception of why that's happening, right? So the measurement has no more validity of any specific theory. That's what I'm trying to say.
I,
Is just because you measure it doesn't mean the application that's currently being taught on why that's taking place, like the theory
mhm.
behind it, is correct. Because the measurement is the measurement no matter what. The measurement doesn't prove the theory. The measurement just is the measurement. Was the measurement
I,
before the theory was even conceptualized?
I would tend to agree with you that if you're measuring something and you know that it's a known quantity, and then you start assigning properties to it and making, asserting things to it, that's not a good look. But I think that gravity is validated, maybe not GR, like that's kind of, I think it's beyond the point. But with gravity itself, Newtonian gravity, there are things that there are predictions that we made that were later validated, like what the gravitational acceleration would be on the poles, because it would be slightly more because they're closer to the center, and you don't have the centrifugal acceleration on any other, like the equator has the greatest. So there are things that can be predicted and then later measured to validate, right? Do you think that's valid?
Yeah, what you said there just had nothing to do with what we were talking about. You just shifted over to Einsteinian gravity. So is that what you're talking about?
No,
Or
I
are
was
we
talking about
talking about the
Newtonian.
theory of relativity, right? Because
No, I was
you're
Newtonian.
what you were talking about previously is some sort of gravity well that was holding these gas particles down. So are you talking about a gravity well that's being created by the bending and warping of space-time? Or are you talking about Newton's conception, or really not even his? He gets falsely attributed with saying that mass attracts mass, which is not necessarily what he said. But his
So
equations are still valid when you're talking about the universal law of gravitation.
sure, like let's talk about Newton, because like I mean I it's somewhat poetic speak, say gravity well. It's not a literal well, of course. There's no fucking water down in there. That's fine. And I'd rather talk about Newtonian because it's just much more, it's less esoteric to us. We don't have physics degree. I don't have a physics degree. I don't have an advanced mathematics degree. I'm
But
not going to be able to validate or disconfirm
yeah,
anything that you might be saying.
but if you're talking about Newtonian, then you're not really. Newton gave no explanation for the causation, right? He just gave the equations based on the measurements on why things are taking place, or to explain the things that are taking place. He gave no actual explanation or theory as to why it's taking place.
Yeah, you just said mass attracts mass, or I think it was like Galileo or somebody came up with that first. But I mean, his equations are literally that: mass plus mass over
Yeah,
the
yeah,
distance
which
squared.
yeah.
Mass times
It's
mass.
literally
Yeah.
it's a
Mass
similar
times
it's a
mass.
similar function to Coulomb's law regarding um, you know magnetic attraction and repulsion, or you know electrostatic
Mhm.
attraction, repulsion, all that fun stuff. So he's just saying mass, which when we boiled mass down, mass just really eventually gets you down to its core base of energy as well. So something very similar to what Coulomb was talking about. So saying mass attracts mass doesn't mean that necessarily is that there's what you would call something intrinsic to matter that is causing it, unless the intrinsic nature of matter that you're saying is the causation would be the energetic, or the, like, I don't know how you would want to define energy, but when we break things down to the positive and negative aspects of the interaction of different energies, that's what we're referring to when we break mass down to its most basic level. When we get at the atomic, subatomic level, that's what you're dealing with. So that's basically what's taking place, is those energies that are inherent to these objects that we say have mass. mass is broken down to those energies, and it's an energetic relationship between the two things. You don't have to have some theoretical conception of space and time, two things that have no actual properties that somehow magically come together to cause whatever, a bending and warping that pushes things together and pulls them apart.
Sure. Are you? Sorry, I'm a little confused though. Are you saying that mass does attract mass? Are you agreeing with the Newtonian idea of it, or no? Was I misreading
Yeah,
you
I
there?
mean, that's the thing. Like, mass attracting mass is a very rudimentary way of saying that, because even Newton said he didn't want that necessarily, that conception of gravity attributed to him, the mass attracting mass thing, because he couldn't figure out what was inherent within mass, which was causing this relationship that he was measuring.
Yeah, but it
So
is a
yeah,
measured
I don't
relationship.
disagree. I don't disagree that mass is attracting mass. That's not really actually what's taking place, because there's something inherent within mass that is causing that, and I think that that's the energetic baseline level of things interacting with other things. That's why it's a very weak force. It's not a strong force like you would see in like magnetic acceleration, or whatever you want to call it, electrostatic acceleration, or things like that. It's a very weak force because it's more incoherent. You have masses that are comprised of all these energies that aren't necessarily in a coherent alignment with our energetic field in which we reside upon. When you do align those things, that's when you get magnetism and you get magnetic attraction, which is much stronger.
A lot of people here do disagree with the statement that mass attracts mass, so it's always good to clarify where everyone's coming from.
By the way, I speak as an individual. I always have, and I always will.
Course.
So just because you hear people saying things, whatever you want to ascribe, whatever label anybody wants to ascribe to me, you don't necessarily ascribe anything that I say to anybody else. You give that label. FYI.
No, I wouldn't. Just
Yeah,
it's good to clarify.
no group is a monolith, right? We're
Definitely.
all just individuals. So, so I'm sorry, Napalm. I don't mean to belabor the point, but are you saying that you kind of do agree that mass attracts mass, but there is something else about like E equals mc squared, that the energy is causing this, maybe some speculation kind of thing? That kind of what that's kind of what I heard, but I don't want
Yeah,
to mischaracterize.
yeah. Everything that takes place in this realm is based upon the concepts of energy and movement, right? Basically all your physics laws are going to tell you about that, right? So it's energy and movement. You have high pressure moving to low pressure. That's a disequilibrium that seeks to equalize itself, and energies do that as well. However you want to define energy, it's a tough thing to really pinpoint down and drill down on what that exactly is, and I have conceptions of it, but
Energy
yeah,
is definitely hard to conceptualize. So the working definition is just that it's something that stays conserved on the balance sheet, like a bunch of things knock into each other, and you look at how fast they were moving before and after the collision, and energy is the number, that can
yeah,
be calculated from their speeds beforehand. That's equal at the end, that has been preserved, just passed around between the objects that collided with each other. So whatever it is, it's something that objects have that they pass around to each other.
yeah. I mean, I very much so dislike the definition of the ability to do work, which isn't.
It's very cyclic, yeah.
Yeah,
That's why I like a conserved quantity that's measured in this way. It is, it's very dry, and it's really just kind of the technical operative, like, what's the thing we're measuring and why do we care about it? But it sort of serves as a functional definition.
yeah. That's the funny thing. We kind of look at many of the conceptions of energy almost in a backwards manner. It's like the smaller the space, the higher the energy can be gathered, right? And we look at an energetic release, which is actually a releasing of energy. So it's a dissipation of energy. We look at that as like this huge, like energetic force, but really the largest energy is that which is conserved right before it's being dissipated in some type of like explosion or something like that.
Mhm. Yeah, a lot of these things, when you drill down on that, there isn't like a metaphysical definition of like what these things are, energy, electric charge, stuff like that. Like all the descriptions of them are just in terms of like functionally what do they do at a kind of operative level. Like you've got your tools on your laboratory table, how do you do a measurement, what type of numbers do you get, what numbers stay consistent over time. But it's very hard to necessarily know from that alone, like what's the deeper thing here that we are measuring.
Look, I hope you don't mind. I got a question about that.
Yeah.
If if the physical world is all that exists, would physics actually be metaphysics as well?
Well, I don't. I think the whole point of metaphysics is that we should be skeptical that everything that exists can be captured by physical measurements. So there's a couple different ways I sort of think about this problem. From on one level of it, I think it's unlikely to imagine that we even could measure and detect everything that does physically exist, because us and our measuring devices are like also made of atoms, and there's like a fundamental problem, trying to like feel and take pictures of things with stuff that's made of the same things. So I'd imagine that there's probably a lot of stuff going on in the physical world that we could know about if we had like a god's eye view of it, but we can't because we're like trapped inside the system that we're trying to measure. So like that's one interesting kind of limitation on what it is that we can actually scientifically know. And then there's other things of consciousness, and I don't mean neurology, but like the hard problem of consciousness, like why does it feel like something to be conscious rather than just going through kind of an automatic set of programs in the brain. I mean, I feel like there's lots of great questions that are truly metaphysical that we will not ever get a satisfying answer to just out of like physics laboratory experiment stuff.
Can I ask you a question?
Yeah.
Yeah.
I was just going to ask about energy, like just a quick question. Like, how did the raw energy after the Big Bang turn into up and down quarks? How did it turn into like these two different natures?
Well, the Big Bang model does not describe as many things, I think, as people often assume that it should describe, because it just says that in the very early universe, the universe was super energetic and super hot. It doesn't give an explanation as to like what set that off. So like the whole visualization of like there was darkness and then kaboom, like that's not even in the model. The model is just there was all this energy, and it was already expanding.
I'm not asking about before,
yeah. But as far as how do you get to matter, so the concept of particles is that they're really wave pulses within these things called fields. So the fields can absorb energy, and the vibrations of the fields are what we then see as particles. So once there's energy in any field, all the fields are interacting with each other, and they can exchange energy with each other. So like a couple example processes of this is a photon of light can turn into particles of matter, and particles of matter can annihilate with each other to turn back into photons of light. And that's seen as just these different fields trading energy back and forth between each other.
No, like after like, how like the Big Bang happened and there was like raw energy, like the raw energy, how did that turn into up and down quarks?
Well, there isn't really like a concept of raw energy. Like I think light is probably as close to it as we could come. Like all energy is motion, and in this context, it is the wave vibrational motion in fields. So every example of energy is in the context of energy within some specific field, and then the fields can trade it back and forth between each other. So there's a question, though, as to what even were the nature of the fundamental fields, all the way back then, blah, blah, blah. But once the fields, if you grant that the fields exist and that they started off in an energetic state, that at least one of them was vibrating really energetically, then it could pass off that energy into the other fields.
Can I just ask one question real quick? If you're saying if you agree that the fields exist, could you give a working definition of what you consider a field?
Yeah, let me uh, quickly pull up a picture here. And because it's
So I
very
understand the
much.
conception, but what is it? Like, what is a field? What is it comprised of? Or is it just a, um, go ahead. You go ahead before I.
Yeah, it's the thing is when you drill down on the technical definitions of it, it's like very cyclically self
Mhm.
referential. So like the
Yes.
way that the concept emerged was I don't know if this is exactly accurate in the history of it, but like one of the ways that people started developing the concept was they did things like sprinkle iron powder around magnets because they were trying to understand how magnets could attract and repel each other. And when you sprinkle iron powder down around a magnet, the iron powder forms into these streaks. And as they were kind of drawing down what they were seeing in their notebooks, the concept of the streak sort of took on a life of its own, and it gave people an idea of like this invisible flow of force through space coming out of the magnets, coming out of one end of a magnet and sort of looping around to go into another end of the magnet.
Mhm.
So the sort of definition of field that we're stuck with is very much just like the thing that is doing that, the concept of the flow of force in space that we can see by its effect on matter. But then later on, it got inverted to actually make our concept of the particles of matter themselves as these energetic kind of concentrations of energy vibrations sort of within the field. So it's like what are particles? What is matter? They are like energetic wave pulses in the fields. And what are the fields? The fields are force in space that can push on matter. So it's like it's a completely sort of cyclic set of definitions that they each just refer back to each other
Yeah.
in kind of a loop.
Would you look
Yeah.
would you look at it as almost like a lattice work of like at least two conjugate fields, and at the intersection points is where you're going to have the arise of like, or the compression or rarefaction of that lattice work of two energy fields, being what would eventually become like what we would consider at some point eventually a particle, right?
I don't know exactly what you mean by conjugate, but I think generally it's
The intersecting. So if you look at like kind of like the way that Charles Proteus Steinmetz would, when talking about like electricity or energy fields, would draw out like the electric and the magnetic and the dielectric and the interplay between those two, and how that wave would send the energy, like the electricity through the energetic field.
So to my understanding, the current model of the kind of field that like particles of matter are in is treated as this sort of fundamental thing, and it's not entirely like there's a lot of things that people today might be referring to as fundamental fields that really arise from more kind of complicated interactions between other fields. So
Right.
sorry, someone's buzzing at the door. I'll have to go get that in a sec. So there's a lot that just isn't known about kind of what's at the base of it all, but like mathematically, like one model that's very popular for thinking about what the fields are is just like a lattice of balls and springs, like a big kind of crystal of things connected to each other by springs, where when you pluck one, a vibration travels out throughout the lattice. But I do want to be clear though that like particles, like electrons that we know of in our universe, they are not the balls in the spring network. The whole balls
Right.
connected by springs, that's the invisible medium of it all. And
Right.
then the particles that we see are the vibrations within it, are areas where this network is excited, so we wouldn't see the material itself, but just the presence of vibrational energy within it.
Right. And that energy is almost like yeah, exactly. So that's good that you conceptualize it that way. I have a very similar conception. I don't feel like the interactions of certain particles based on their fields and their interplay of their fields. I look at that from kind of like the interplay of like musical notes based on certain chords and various octaves, and having harmonization between octaves and chords. And I translate that into kind of like energy. That's how I help myself conceptualize the interplay there, if that makes sense. And the harmonious points is when you get the higher energy, and that energy travels and it can interact
Yeah.
within its own octave, but has a different interaction with other octaves, if that makes sense. And you also have
Yeah,
cancellation
no,
and
that's
you have
all.
Can I
amplification.
ask a follow-up
Sorry to
question?
get into all this, and then I gotta jump up to get the door. But like, yeah, no, there's lots of ideas of how to like fit everything we know into some clear harmonic pattern. And the unfortunate thing is like it's not there yet. You know, like the models of physics are not there at the point of finding some grand unifying organizing principle. So like it's very ad hoc at the moment of just kind of like people have rigged up a bunch of math to describe a bunch of hypothetical fundamental fields to like force out of the math something that can model particles as we see them. So we're still not at that kind of clean, grand, unified, sort of beautiful underlying picture that people hope for that maybe does or doesn't, you know, exist. But I got to run to the door. Sorry, but
Appreciate it.
Well, I was just gonna say, like, wouldn't it be fighting entropy for these first particles to form out of like raw energy? You know, wouldn't it be fighting entropy
I
for
don't.
this organized
He,
particles of up and down quarks to form?
yeah, he had to run, but it sounds as though he's probably not a huge fan of that idea or concept of the Big Bang, or at least skeptical of it, because it seems to have no explanations like you're talking about for some of these fundamental things. But I don't want to speak for him. But did he leave? I think he left. But I think he probably has a very extensive physics or chemistry background, the way that he was speaking, because I feel like, you know, he might actually be even more open to his things being incorrect than somebody like Jay Ace, because when you push Jay Ace on a similar line of questioning, he'll give you somewhat similar answers to what that gentleman was talking about. But the average person will just be like, "Oh no, you're stupid. Particles are this, and you don't think particles are X, Y, and Z," and they just have a very rudimentary idea or conception that was taught in, like, you know, basic physics books in high school and college.
What's the topic? Sorry.
Floor is open.
That sounds like Dr. Bliss.
Why is it open for anything?
Sure. What's on your mind, man?
I've been just chatting a little bit about his boilers underneath New York, and purposely put there by Thomas Edison. And Thomas Edison was doing electricity, and I would imagine the whole boiler system underneath New York is actually deliberately done so that they could generate electricity, of which today they use the steam generation for something else, if you know what I mean. I mean, I don't know if they don't make electricity using the steam boilers they've got underneath New York, but there's certainly that was the whole idea initially with Thomas Edison. So it was nice to see that there was a connection and it wasn't just random. And that was it really. It was kind of, yeah, that's my thing. But I know you possibly guys were probably talking about Earth shape and stuff, or maybe science. So I don't know what you were talking about before, so apologies. But
I was
I
actually kind of along those lines. We were talking about, like, what is energy, the conceptions of energy when you boil everything down, everything that we could consider matter has what is called mass, and when you boil mass down to its most fundamental level, it's actually energetic.
okay.
And we started getting
Yeah,
along those lines. Yeah.
I was in on that conversation about 4 hours ago, 5 hours ago. Um, yes, I heard the conversation, so I guess we're still, on the tail end of that. I'd say energy is one, and it'll always be one, a bit like that, whatever, container or whatever you want to call it. But if we lose, yeah. What's energy? I think energy, in our case, if we lose energy to space and we absorb energy from space, then the energy we are as one with the energy around us, um, and we exchange with, yeah. Uh, if the energy from the outside is resisted or sped up between the two layers, Earth being one and the upper being the other, then that resistance there can cause uh, I guess an effect elsewhere. If you slow down one thing, then something else will speed up somewhere else. You know what I mean? It's always going to be a one. It's always going to be on. Yeah. Sorry. Thank you. But yeah, I remember the conversation about maths and this, that, and the other, and such and such. And for me, electricity is light that we just can't see. So therefore, they are one and the same. They're just one cycles more than the other, or something.
Yeah. I feel like everything would be what we would consider light, just at various energetic levels, for sure.
Yeah. So it's only what we perceive. It isn't possibly or necessarily what is actually happening. We could all be translucent. We just can't see it. Because we don't have that ability. Our eyes are too slow as well to flicker or refresh it, that sort of thing. So if everything is one or two things, it's either matter or it's not, and whatever is not is what holds the matter together. And what are those things are? I'd say oxygen has got a big part to play in a lot of stuff. Without oxygen, the electricity can't do anything. It'll just be inert.